Okay, hello everyone. For this video, we're going to discuss the set Persediaan. So, let's see the questions that we have in set Persediaan. We're going to start from the questions from section A, question number 1. So, let's see. Section A, question number 1. In these questions here, what we have is that um, we have a questions of 9 marks, where these questions is contribute from chapter 8, which is limits and continuity. And let's have a quick look, go through the overall questions, what we have in these overall questions. So first of all, according to these questions, you are given a functions fx in the form of square root of x squared plus 9 divided by 4 minus 2x. And now what they want us to do is that find the following limits if exists for 1, 2, 3. So using these functions to find the corresponding limits accordingly. And then B, use properties of limits, find the answer for the value of k, where the k is a constant located in these two positions. So let's see how we're going to solve for these questions here. In total, we have 9 marks. Start from questions A. Let us go through. So in questions A, let me zoom it in a larger scale before we begin. So in questions A, what we have is that we have limit x approach to 4 for fx. So we start the solutions with limit x approach to 4 for fx. Substitute the functions in. So I suppose this is the functions that we have accordingly in the writing. Limit, then followed by the functions. So to do these calculations here, we will begin the calculation in the way that we always try our luck that we do direct substitution on this value here into the function and see that does this result happens to give us a real number solution or not in the overall functions calculation. If yes, that's the answer. If it happens to have determinant like, for example, 0 over 0, constant over infinity, 0 over infinity, infinity over infinity, that kind of situation, or constant over 0, then we need to think about the strategy. But if the result is just a real number, then we can just go on for the calculation. In this calculation here, we find out that when the time I substitute 4 into the numerator parts and denominator parts, both of them is have some real number answer, where the result can just calculate out as following by direct substitutions and simplify the answer. I suppose the answer is just 5 over minus 4. That's it. Can be solved just by direct substitution. Don't have to think so complicated thing like divide by highest power denominator, that kind of thing, or multiply conjugate to solve the questions. Go on. Next, for A2, same functions we have. Now we want to have the case of a one-sided limit x approach to 2 from the right-hand side, 2 plus, a value slightly greater than 2. So how we solve for this question here is that let us try to plug in this value 2 here into the function and see what's the result that we have by direct substitution. Do we happen to have the situation that we have a real number answer or we have indeterminate form? And in these questions here, you find out that I have the answer if I do direct substitutions inside for calculations. I suppose I have square root of 13 over 0. And this result here is supposed to give me answer either plus or minus infinity. But which one is it? We need to determine. That's why I put the question mark here. So how we determine whether it's a plus or minus? So use a test value. Let's say 2 plus. We use a test value which is 2 plus a small number which make it slightly greater than 2. For example, I have 2.01. Then once again, I plug in inside the functions here and try to see what is the sign, whether it's positive or negative. So in your calculation is that you write back the terms given in the questions, follow, substitute the functions, and Then by the time you substitute 2.01 inside for calculation, I suppose you have the result. Find out is that you have the result equals to negative. A negative figures will be coming out. Again, we're just interested with the sign that produced by using this test value. What's the exact figures? We are not interested. We're just interested with the sign because we already identified in the earlier step. We know for sure is plus or minus infinity. So we just want to know the sign for plus or minus only. As a result, here we have answered negative infinity. The answer will just as simple as this form here. Of course, if you think that there seems that no calculations is written, just direct answer, is it acceptable or not? But right, yes, that is a way that we're going to have the answer. Of course, if you feel that not secure, you may add in step like this lah. For example, square root of 13 over 0 minus, what is the 0 minus refer is, you find out that if you have direct substitutions on this part here, you have a value that is slightly smaller than 0, a negative value that very close to 0. That's why it's 0 minus. But if you're not sure how to write in this formation here, then it's better you don't write lah. If not, lagi buat lagi salah lah. Okay, so go on. Next, I have the case of x approach to negative infinity. Okay, although it's approach to infinity, we still try our luck for direct substitution. When the time you substitute infinity inside, you find out that the top part you have positive infinity over positive infinity. So we have the case of indeterminate form with the way of infinity or infinity. So in order to avoid this type of situations happen, what we're going to do in our calculation later is that we will take these functions here. We're going to divide with something. And the something here is actually we're going to divide with 1. But of course, it looks stupid to divide 1 in this form here because before and after the result is the same. But why I want to emphasize divide with 1 is because how come we can just suddenly divide or multiply something sometime in our calculation is because we are actually multiply or divide with 1 in our calculation, just like this case here. We actually divide with 1, but of course not the 1 in this form here. As divide 1 in this form here, the value maintained, the form also maintained. So the problem remain unsolved. So we're going to divide with 1 in some other form where we have the value happens to be maintained, but the form is changed to something that it will help us to go on further to solving it. So the one here that we want to divide is in the form of, we refer to the denominator, look for the highest power of the highest power term, in here is x. So we're going to divide 1 in the form of x over x for top and bottom. However, if you realize if I divide this one with x over x, what happened is the result I have square root of x squared plus 9 over x on top. The bottom I can divide it easily. 4 over x minus 2. So this part is still remain unsolved. So what I need to do is that I try to find out, is that possible that I change this form, change another equivalent form of this x here in the form of square roots, so that this square root term I can simplify it. And I find out that based on the definition of modulus, it is defined in the way of x for x greater than 0, negative x for x less than 0, and also defined as square root of x squared in the second definition. So as a result, we find out that for greater than 0, the square root of x squared equals to x, whereas for the case of less than 0, we have the case of x is this the square root of x squared here, as you can see, is equal to minus x. And now we need to know whether in our calculation here, this x here, we should use this one in blue or the one in red. The highlight in blue or the one highlight in red. How we determine is that you refer to these limits here. You see x approach to negative infinity. So if x approach to negative infinity, I'm referring to the case of x is less than 0. So for x less than 0, which is the case I refer to x approach to negative infinity in this question here, square root of x squared is actually equals to negative x. So therefore, x is equal to negative square root of x squared. Therefore, this part here, I would like to replace with negative square root of x squared. And therefore, the divisions here, it can simplify. The top part becomes square root of 1 plus 9 over x squared. Divide by. So the term just now is still maintained. And watch out, there's a negative sign here. So the negative sign, we keep it outside the square root. So therefore, in your calculations, you will find out that we begin with writing the limits in terms of fx, then substitute the fx, which is the functions. The next thing we do is that we're going to divide negative square root of, we're going to divide negative square root of x squared over x, where the top x here, we convert accordingly. And therefore, this is the result that we have. In your solution, you don't have to show these divisions that I draw in green. Just make sure that you have this result here correctly as I type will do. Now reach up to this moment here, by right, you find out that with the substitution of infinity for those part with x, you find out that those part I highlighted in yellow here will turn become 0 as what I have for the result here. So I have my answer equals to positive 1 over 2. So there goes my answer for A part 3. Okay, go on. Next, by using the properties of limits, find the value of k for these terms here. And for solving these questions here, let us recall on some of the properties of limit that are important for us to take notes. So since this case here, it discussed about limit x approach to 4, so I will use limit x approach to 4 to explain on the properties of limit, or we review on the properties of limits. The first properties that I want to refer is that, let's say I have the case of limits of functions, let's say, or some terms lah, a plus b. It can break it into form of limits x approach to 4 a plus limit x approach to 4 b. I can break it into two limits and then join with the operation between the a and b. If it's a plus, then it's like this form. If it's a minus, then the plus sign will change to minus. So this is the first properties. Next, the second properties that I want to recall on using for this question here is that if let's say I have the case of limit x approach to 4, if I have, again, I use a and b as reference, a divided by b, then I can break it to become limit x approach to 4, a divided by limit x approach to 4b. Again, we break the limits according to a and b, as you can see here. Then one more last one, I think, before we try to solve the question is that it will go on in the case that if I have limits x approach to 4, and if let's say I have the case of a constant multiplied with a functions, in here I need to mention that k is a constant. Just now the a and b, it can be constant, it can be functions. So if k is a constant, I can have it factorized outside the limits. Where this constant here is, it won't affect by the x approaching to 4 here. So we can factorize in this way here. Okay. Then for this 4 case here, for this three properties here, now we try to solve the questions. Okay. So the next line of the answer that I need to display is, I think it's already cut short. So let me show you step by step before I go for the next line. If you need this step here as a reference, but of course it's not compulsory. If you're able from here starting, copy back from the questions, and then you go for the next line, then you go ahead. But now what I want to show you is the story before I reach this next line here, which is, first I would like to apply the properties number 2 here for the left-hand side terms here. Let us just focus on the left-hand side terms here, the changes on the left-hand side terms here in my writing of the properties accordingly. So what I find out is that, first I find out that it can break into form of limits x approach to 4, top and bottom. So I have 3 minus kfx for the whole thing. At the bottom, x minus 2. And of course, to have the solutions look complete, the right hand side equal to 0. Sorry, equal to 0, equal to k, not equal to 0. Then further, what I do further now is that I want to go for properties number 1. Where now we focus on top, the top part here, apply properties number 1. We have limit x approach to 4, 3 minus limits x approach to 4, kfx over bottom. I would not like to split them. I would not like to split the x and 2. I just maintain alone because just in this form here, x minus 2 is good enough for us to proceed to do substitution and get the answer. And then don't forget the right hand side equals to k as well. So from what you see now is that we apply properties number 2, properties number 1, and now lastly I want to go for properties number 3, where the properties number 3 I would like to apply on this part here. I factorize the constant k. So therefore it will reach to the result I have here. And all this can actually done in one step. If after you're already very clear about the properties of the limits, you can do this all in one step, like what I have in my solution here. Then now we try to calculate our answer. Okay, so watch out that I try to highlight in a different color for each of the parts. So for the denominator just now, I didn't break it according to properties is because this one we can evaluate easily by substitute 4, calculate the limits by direct substitution of 4 inside for further calculation. Then follow by the part that I highlighted in yellow here, limit x approach to 4 fx. If you realize this is the answer that you get from part A1 just now, the answer is 5/4. We're going to substitute 5/4. The k is maintained here for reference. Then next, the part that I highlighted in red now, this one, we need to refer to the properties of limits. And actually one more properties of limit we're going to refer is that if let's say I happen to have the situations that if I limits, let's say x approach to 4 for k, where k is a constant, I need to make remark k is a constant. So this limit will just equal to k itself. So this is especially for the case of constant. So now what you happen to see after you understand all this idea is that first the one that highlighted in red, it will reduce become 3. For the part highlighted in yellow, we substitute, it will turn out to become 5/-4. The part highlighted in purple, we direct substitution for calculations, we have 4 minus 2. The right hand side maintain the same equals to k. Then from here, we try to simplify to get our result. So the next line, what happened in this calculation here is that what I do is I do two things at once. I simplify this part here to become 2, and then I multiply 2 on both sides so that I can get rid of the denominator here. Or maybe you can also think in the way that you bring this multiply with k. Then follow, simplify, you shall able to get the answer k equals to 4. Okay. This part here, maybe you see there is some step that seems to be missing. So from here to the next line, from this one to the next line, we can see in the way that, for example, we consider, let's say I move the 2k on the other side, I will have it as -3/4k. equals to -3. Then from this one to next one, I divide both sides with 1. I divide both sides with -1. Then I got my result as following. And of course, you can see in another perspective, maybe not in this way here, where you move this term all the way to the right hand side. So I will have it as 3 equals to 3 over 4k, and therefore answer as follow. So we have k equals to 4 as the result here for B. So this is how we get the solutions for question number 1 in section A from chapter 8, limits and continuity. And in these examples here, in this question here, we solve regards on limits only so far. Next, question number 2 on part A. So these questions here, it contribute for 9 marks and is from chapter 9, differentiations. And in these questions here, mainly test our knowledge on differentiability. As you can see that it was told that the functions in here, I suppose is a function f, is differentiable at x equals to 9. There's some missing text here, I think, in my copy and paste here. And then you was told that f prime is equals to 5. Then evaluate these following limits. So what is the info that we can know from the sentence, the first sentence here, in order to evaluate the flow limits? And what is the meaning of evaluate is that we want to find out the value of this limit. This limit here have a certain value, a certain real number value. So first, according to the questions, you were told that f is differentiable at x equals to 9. That means this f prime 9 is something that valid, and valid in the way that it gives us the value of 5. And if let's say this f prime here is happen to be valid, that means what we happen to know is that the limits x approach to 9 for the function fx minus f9 over x minus 9 exists, and it is equals to f prime 9. And of course, further info is that it is equals to 5, of course. And how does this help us to calculate the calculation below? So the strategy to solve this question is that from these limits that we want to find out here, let us try to relate these limits here with the limit I highlighted in yellow here. And why I want to relate with this limit highlighted in yellow here, so that if you're able to relate with this one highlighted in yellow, therefore, this whole limit highlighted in yellow can be converted into f prime 9 and further substitute to become just a figures of 5. So in other words, we try from these limits here, we do adjustment mathematically and get this limit highlighted in yellow so that we can apply the information here to substitute become 5. And what we can do, let us try to see, compare these two limits here and see what are the similarities, what are the difference. First, we find out that both of them is limit x approach to 9. In fraction form, we have fx minus 9, fx minus 9, but the denominator is not the same. What you find out is not the same is that the one that we want to find out, we have x plus 1, square root of x minus 3. But what I actually want to have is that I want x minus 9. I don't want these two terms here. And further, of course, if you try to do direct substitution for further calculation, it cannot be done because you will get 0 over 0. So what I want to do now is that let us try to find a way to, from these two terms here, these two factors here, we do something so that we have x minus 9 happens to exist. And if you happen to realize, when the times square root of x minus 3, I multiply with square root of x plus 3, it will happen to create for the result of x minus 9. So now, this is the clue for us to solve the question. I want to multiply this one on the denominator so that I can get x minus 9 and further think of the strategy to solve according to this info. And of course, I cannot just suddenly multiply square root of x plus 3, but instead, I can multiply in the way that, like this. I multiply the function fx minus f9 over x plus 1, square root of x minus 3, multiply with square root of x plus 3 top and bottom. And why we can out of sudden multiply these terms here and yet our calculation still valid is because this item here you multiply is actually you multiply 1. You multiply 1 before and after, the value is actually the same. But of course, the one in this form here that I highlighted in blue, it will change the form. It have the same value before and after, but it will change the form. And the form that it changed, suppose it will help us to simplify our answer. So in our calculation here, the important contact that I want to have is that I want square root of x minus 3 and also square root of x plus 3, they multiply each other. The rest of them, we don't expand them. Jangan multiply yang lain. Ya, hanya multiply dua pasangan ini saja. So therefore, it's still in terms of limit notations. The top part maintained. The square root of x plus 3 don't multiply inside, so I just have it maintained outside. This is the one that's still maintained outside. And then for the two that I highlighted in yellow, when the time you multiply, suppose now I have x minus 9 as a result after you multiply. Now, before we go on further, you shall see that we are almost there to get the form that we want from this so that I can get f prime 9. And let us have a quick check. So once again, let us have a quick check. On these limits here, what is the thing that we need? And so far, what we have achieved. And what else modifications that I need to do. So first you find out that, of course, we have the same limits. We have the same limits pending. I have fx minus f9, x minus 9. So all the term I need already there. In order to achieve the overall here to substitute f prime, what I need to do next is that let us get the x plus 1 grouped together with the square root of x plus 3 together like this form here. So now you see the terms I highlighted in green is all the terms and also the arrangement I want to have in order to achieve these substitutions. Then reach up to here. Next, what is happening in my calculation is that I apply the properties of limit as you learned just now in the last example. If I limit x approach to 9, if I have a multiplied with b, I can break it become limit x approach to 9, a the whole limit multiplied limit x approach to 9, b. Oh, sorry, I think we didn't mention this property just now. Because just now we mentioned about plus, minus, divide. We didn't mention multiply. So this is the property we are using. Now we will break these two into two separate limits. And as a result, this is what we have. So this limit that I highlighted in green now is the one that we can substitute become f prime 9. The other limit that I highlight now, this one, you don't have to do any complicated technique to solve it because it can just solve by direct substitutions. What we know from the question f prime 9 is actually equals to 5. Simplify this part here that we have calculated. It will be 6 over 10. This one is the one that highlighted in red. The other one is the part that we substitute from f prime 9 equals to 5. Again, check back. F prime 9 equals to 5 is given in the questions. Therefore, I have the answer here now equals to 3. So this is the full solution that we have. So we try to relate with the informations from the differentiability in order to solve and find this value of the limits. Continue. Next, section A, question number 3. This questions here is regards on chapter 10, the applications of differentiations. And let us try to see how to solve for these questions here. According to the info, you were told that the point 20 and 04 are the stationary point of these functions here. Then by first derivative test, determine the nature of the stationary point. So watch out for this question here. If you realize, what is the routine calculation that you always do in the tutorial book is that they give you a function and then they require you to find stationary point by yourself and then you test the stationary point to determine the nature. But today, stationary point already identified for you. You don't have to spend time to find the stationary point. You just need to perform the test to determine the nature. The nature here means that you want to know whether the stationary point is the case of maximum, minimum, or maybe inflection. If let's say we find out that the test failed, or we have some things that we cannot determine whether it's extremum, which is maximum or minimum or not. So this is what we happen to find out. Or just in short lah, determine the nature. We want to know first whether is it extremum point or not extremum point. If it's an extremum point, what type of extremum point? If it's not an extremum point, then we further try to test, is it possible to be an inflection point? And in this case here, the nature must test specifically requirement using first derivative. You shall not use second derivative here. And now go on. After that, hence sketch the graph. But right after you get the result for part A, you can sketch the graph. And let's see how can this be done. As in part A require us to do first derivative test, so I must have the first derivative, take the function fx, we differentiate it. So differentiate constant 4 will be 0, so we don't have to write anything. Differentiate 3x squared, I will have the result as minus 6x. Differentiate negative x power 3, I have 3x squared. So this is my first derivative. And now I want to do the test. According to the question, stationary point already there. And what I need to do is that identify the x coordinates of the stationary point. And then consider where does it located in the number line so that I can identify which are the interval that I will consider in my test. So in the first derivative test, usually we will construct a table. With the first row, we start with interval, where we're going to refer from this number line later, followed by test value. The test value here in red because it's not compulsory to have that. But I treat you as a beginner in this solution here. That's why I have the test value here as well, written. Then next, I want to have the result of the first derivative test. And in here, I just interested with the sign, whether in the calculation later I have positive or negative. And then lastly, I would like to refer to tangent. The tangent here is actually refer to the slope of the tangent, whether from left to right, the tangent is increasing or decreasing. Then interval is always start from infinity until infinity. So the first interval here is in negative infinity until negative 2, open brackets. Follow 2 to 0, negative 2 to 0, 0 to infinity. Everything is open brackets. Then next, by the test value, choose one value from each of this interval. Choose some simple value, which if possible, we can without use calculator. We can just, without using calculator, do my calculation to get the answer for f prime to know plus or minus. Let's say I choose negative 3, negative 1, 1. And when the time I substitute negative 3 into the first derivative, I find out that the result is negative. So the tangent will be from left to right is decreasing. Substitute negative 1 into the first derivative. I have positive sign for f prime. So from left to right, increasing. Finally, substitute 1, I have negative, and then decreasing. What does this tangent here happen to help us to determine the stationary point whether it's maximum or minimum is in the way that if you realize between these two changes of the gradient, we have x minus 2 in between them, within them. Because as you can see, these two interval doesn't include minus 2. And what we know about x equals to minus 2, it is a stationary point. So the gradient is a flat horizontal line. Same go for x equal to 0. It's supposed to be a flat horizontal line. If I combine all these 5 lines here in one stroke, so what you happen to see is that we have from left to right going down, flat line. Then from left to right going up, flat line. From left to right going down. So this is the part of my stationary point. And if this curve, this line here, I have all this corner point here. Turn into curve. So I will have a curve look something like this. And we can see that the stationary point here is corresponding to here. The other one corresponding to here. And from the curve here is obviously to see that this is a minimum case. The other one is a maximum case. So at this point here, minimum is located at x minus 2. So therefore, the minimum point is minus 2, 0. The maximum point occur at 0. And this is how we get the solution. This drawing here at the side, just for explanation, you don't have to draw it out to observe lah, of course. Okay. Once we get these here things here done, the question asks us to sketch graph. So sketch graph, by right, you'll find out that first derivative is very helpful as we have this rough sketching here just now. By right, it should help us to determine how the graph is being sketched. So let me redraw this curve here and label in the maximum and minimum point according to their coordinates. And then we try to insert according to this reference of these 2 points here to insert the x and y axis. And then we try to check the needs for us to find the x and y intercept accordingly. So, but we put in the x and y axis first. So what you find out is that y-axis is actually the line of x equal to 0. So you find out where should I put x equal to 0 is that it's a vertical line, of course. Let's see on this curve here, where is the part that we have the coordinates of x equal to 0? I find out that this is 1. So by right here is my y-axis. Then we follow by x-axis. X-axis is actually when the time a horizontal line where y equal to 0. A horizontal line that pass through y equals to 0. So coincidentally, we find out that this is what it happens to look like. It will pass through this point here for the x-axis. And you should see that there is one more x-intercept I need to find out. So maybe we spend some time to do calculation on this point here by using calculator, where we can try to figure out the answer in the way that 4 minus 3x squared minus x power 3 equal to 0 in your calculator. Then you press the button shift, calculate. They will ask you what is the x value to use. So maybe now you have the diagram here. Try to choose an x value that around this point here. So I find out that the only point I can identify close to this is 0. So I use x equal to 0. So you substitute 0. Maybe depends on the type of calculator you have. You need to press equal, maybe for 1 time or 2 times, depends on the mode of your calculator. Or some of your calculator, the old one, you need to press shift calculate for 2 times and then wait for the result. Then you will get this x-intercept. And the final answer for the graph, it will look something like this. as you can see, we somehow able to find out the x-intercept is equals to 1. So therefore, for the graph sketching. So in fact, you find out that later, when time you want to sketch the graph of polynomial, the first derivative test is very helpful. Where you observe the increment, decrement of the tangent, then connect them with a horizontal line of the stationary point, like what I do just now initially in the diagram in red here. Then all the sharp corner here, you make it round, then this is the curve that you should see. So there goes the answer for B. Okay, go on. So next, I would like to refer to section B, questions number 1. 5 marks is given for these questions here, and the questions is come from chapter 1, number system, and to be specific lah, the one that actually tests here is complex number from the number system. And let's see what we have in the questions here. So you're given a complex number named Z is defined in the form of 4i multiplied square root of 3 plus I. Then they want us to express this Z here in the form of a plus bi, where a and b are real number. So what is actually asking in this question here is that they're actually asking us to express the answer in Cartesian form. Or sometimes you may see that they call as a rectangle form. They want the simplest form where we have a real numbers and also an imaginary number, whether they plus with each other or minus with each other. And how can we get this answer here is that, okay, so guys and girls, first we need to recall on some simple knowledge on complex number, where I is actually what we call as imaginary number, where it is equal to square root of -1. If let's say I have the case of I squared, so we square this thing here, we get the answer as -1. And we're going to make use of this info here to help us to solve question and get the answer easily for part A. So according to question, Z equals to 4i squared multiplied with square root of 3 plus I. So if you realize, as we mentioned just now, I squared is -1. So this is actually equal to -4 multiplied square root of 3 plus I. Then we expand the -4 inside. This is the result that we have. So we have it in the writing in the form of the A, the B, I. And please, although you see there is a plus here that they request, but how come between them is minus? It's because you can also read this thing as this way here. So it's A plus BI. Your B is -4. So it's still valid answer. Then part B, they ask us to hence find the exact value of ARG bracket Z. This ARG here is referred to the short form of argument. What is argument of Z? So for your information, argument of Z is that in terms of diagram, if this is the diagram, the diagram that we call as the Argand diagram, something that looks alike like Cartesian plane, but the vertical axis, we don't call it as y, we call it as imaginary axis. And then we have this one as what we call as the real number axis. The argument is actually referred to, for example, we try to plot our complex number inside the Argand diagram. Let's say this is the locations. For example, I just simply plot somewhere. This is the locations of my complex number. Connect the complex number to the origin. And then the argument will happens to be refer to the positive side of the real number axis. We do rotation either anti-clockwise or clockwise all the way towards to this diagonal line here. And the rotation shall not exceed 180. So in this case here, this is the rotation that we have, and this is what we call as the argument. the argument. And one important information to take notes, the argument of Z is not the same as arctangent modulus B over modulus A, where Z equals to A plus BI. It is not equal in general. Secara umumnya mereka tak sama, but a lot of students have been understood that they are the same. In general, they are not the same. They only is the same in a specific situation, where the specific situation is that, let's say the complex number is located in the first quadrant, where both of the A and B, the real and imaginary part is positive, then only they are equal. So in general, they are not equal. And let us try to check on these questions here. Where is the argument in the Argand diagram before we try to do calculations? Okay, so let's see. It's a good idea that I just have it still maintained in this form here. Now we refer to the Argand diagram. So this is the imaginary, this is the real. We find out that the real part, which is this one, I have negative square root of 3. Negative in the real number axis, maybe somewhere on here. Imaginary also negative, negative 4. So negative 4, maybe I have it somewhere here, negative 4. Combine these two to form a point. So this is the location of the complex number Z. If I have this point here connected all the way to origin, I have a red diagonal line here, where the length of this line here is our modulus. And now from this line here, I would like to observe where is the argument. So again, the argument is actually referred to the positive side of the real number axis. We do rotations, whether it's anti-clockwise or clockwise, to get to this diagonal line here. And the rotation must be less than 180 degrees. And the choice here now is this one. The rotation is in these directions, which is less than 180 degrees. And this is the argument of the Z that we want to find out. And in order to get this argument here, for this case, I need to do some calculations. And the calculations is that we try to calculate out what is this angle here, where this angle here is alpha, which is actually the angle between the full length of the real number axis and this red diagonal line. And of course, the angle must be the acute angle that is less than 90 degrees. And if you realize the alpha, I doesn't have any arrow, because the alpha, there is no direction considered. And this answer is just a direct answer from calculator. And what is the alpha here? The alpha is equal to the arctangent of modulus B over A. In other words, this is actually the alpha. The argument is not always the same as the alpha. As you can see in this diagram here, they are not the same. But we can relate them. And how we can relate them is that we find out, to find argument, I need to consider two things. First, I need to consider direction, whether it's positive or negative directions. So in the rotations here is rotation in clockwise directions. So I have it as negative directions. So again, this is negative direction. Here is positive directions. So now we have negative direction in the diagram here. And what is the size of the angle for argument? We realize that alpha plus argument is 180 degrees, which is pi in terms of radian. So therefore, the size of the argument will be pi minus alpha. Or maybe if you're advanced enough, you can at least expand inside, become alpha minus pi. So in my calculation here, I start with the calculations of alpha. If you realize, although your A here is minus 4 square root of 3, B is also minus 4. But how come in my calculation here there's no negative sign? It's because the modulus suggests us that we ignore the negative sign in calculations, then press calculator for direct answer. And I suppose my answer here, the exact value is pi over 6. Don't convert into decimal. Because if you convert it into decimal, it will no longer have the exact value. So the answer need to be written in terms of pi. Then if alpha is pi, then argument will be pi over 6 minus pi, and then the answer is negative 5 pi over 6. So this formula here is based on alpha minus pi. So this is how we get the answer here done. So please, the calculation of argument is not difficult. But of course, it's not too simple that you just direct make it equal to alpha. The argument is not equal to alpha, which is not equal to, the arctangent in general. Secara umum tidak. Dia hanya akan sama if let's say in the diagram drawing it located in the first quadrant here. Then they are the same. If not, basically they are not the same. So recall back in your lecture notes on the 4 cases. When the time your complex number drop in different quadrant, how is the calculation is done and what's different among them. The concept of calculating is the same. But the way of writing the solution, of course, is a bit different. Okay. Go on. Next. Question 2 in section B. This is questions from chapter 2, and let's see what we have in this question here. So in this questions here, question 2 in section B, in total, marks allocated is 11, suggested by this set paper here. So we have two parts, A and B. One A is 5 marks, B is 6 marks. And let's just roughly go through what is happening in the question. Then we try to solve it one by one. Okay, first, question A here, we find out that this is actually the question that about we would like to find the value of x that satisfied the following equation. So in other words, they actually ask us to solve the x in this equation here. And this equation here, as we can see, is regards of log equations. It's just log equations, don't have square root, not involve a calculation of square root. Maybe involve a little bit on the indices in the end of the calculation, but basically it's about log. So we try to think about the log equations to solve it. The strategy to solve log equation to solve it. And then one important instruction given here: give your answer correct to 2 decimal places. What is 2 decimal places refer to is that after the decimal point, we have 1, 2 numbers behind. I don't care whether this is 0 or there is some number in front, but always keep in 2 digits behind the decimal point. So this is 2 decimal places. And how to solve it specifically, we will analyze later. B, they want us to find the solution set of the following compound inequalities, where the compound inequalities is actually referring to we have a combinations of 2 inequalities with the relationship of or in this case here. So what I need to do is that from this case 1, I solve the solution for it. Let's say solution S1, solution 1. Then from case 2, get solution 2. Take these 2 solution, relate with or, which is union. And then that will be the final answer. This is what happened to solve for question B. And now let us start with specifically and also in details on how to solve question A, the equations of log. So according to these equations here, we have log equations, and when the time to solve log equation, my suggestion to you is that first we try to observe the log that we have, do they have the same base? And if they have the same base, then so how? If not the same base, then how? So in this case here, we find out that we have the log of base e, we have the log of base x, we have the log of base 10. This is actually base 10. So among these 3 base here, e, x, and also 10, what we're going to do now is that we're going to convert them into the same base. And among these 3 choices here, for sure, I don't want to convert into base x. I don't want to convert into unknown base because not to say can't solve, but sometimes it makes the solving process more complicated. So now our choice is between E and also base 10. Which one is the one that we should choose to change? Let's just try to see the terms that we have for base E and base 10, the two terms we have there. We're going to decide in the way that we check these two logs here, which are the one that we can simplify, which are the one that we cannot. So we go for changing base according to the one that cannot be simplified. And in this case here, we find out the case of base 10, we can actually simplify because we notice that 100 is actually 10 squared. So we have log to the base 10 squared. And this one can simplify, become 2 according to the law of log. So no longer have log, just remain with constant 2. So therefore, our choice is we change to base E. So we start our calculation in the form of the base E ln x maintained. The terms here, log to the base xe, I want to change the base and be aware the 3 here, please don't bring inside to the log to become e power of 3 is not useful to bring in this way here and it's meaningless. So we just proceed further with the change of the base. So in here, just have a quick calculations on how to change base. I want to change to base E now. So I have log to the base E, top and bottom. Again, log to the base E is actually ln. I want to write in base E here so that easier for us to see the properties on the simplification. So I have E x. Log to the base E is actually 1. Bottom, where we just simplify as ln x. So as the result, if I have the case of multiply with 3, so it will be multiply 3, lah. And this is what we have for the result. Here is ln E, which is also equal to 1. If you want to just write 1 like this, want to write 1 over ln x like this, also all right. In here, I have my answer. Start with this result here, where I have ln E over ln x. Then just now, this one is actually log 10 to the power of 2. And later we can simplify our answer as following. It's important to show that this process of calculations instead of direct press calculator for result. Then reach up to this point here, what we find out is that we're going to solve by doing substitution so that we can have everything look even clearer to solve. So in here, I do substitution, let y equals to ln x. By right lah, at this moment now, you're very clear lah, if you have some log equation like this, it somehow deal with quadratic later, and you will have a better vision to do substitution. Of course, substitution is not compulsory, but it is very recommended to do so that the solution later, it will look simpler. So now, substitute all the ln x become y. Follow, multiply everything with y. I will have a quadratic equations as follow. Then next, I'm solving in using the classic way. I do factorizations. And by right, I have the result y is minus 1 or y is equals to 3. Reach up to here, don't get too excited to start to decide want to reject which answer. You only reject the result after you do replacement, or I should say, you replace back this y here into the term x. So I have become ln x equals to minus 1, ln x equals to 3. So reach up to this moment here, back to x only, you decide you want to reject or not. And in this case here, both of them shall not be rejected. Both of them is the answer, where recall how to from log equations we change to index equation. So ln x is actually log to the base ex. So the way of solving it is that the x term maintain, the base of the log become base of index, constant b here, power. So as a result, I have e power of minus 1. If you try to do calculation, this is actually calculation of 1 over e, and we have the answer equivalent to 0.37 as required by the question, 2 decimal places. We press our calculator and then convert into 2 decimal places. The other side, e power of 3, convert into two decimal places. I have 20.09. There goes my answer for x. Continue. Solve the compound inequality. As I mentioned just now, the strategy to solve this question here is that from case 1, we go all the way until get solution 1. Then only we refer to the second case, case 2, all the way until solution 2. Then only we try to connect them with the word or for union. So therefore, in our calculations here is that case 1, I just have a simple linear inequalities here. So the next step what I'm going to do is that I would like to multiply 4. Or some of you may can think in the way that I bring this 4 up. And why I can bring this 4 up in this case here? Why previously it was told that by right you cannot simply bring something down to up, because previously you're not allowed to bring anything up is because you don't know the item that you bring is a positive or negative value, or the number that you multiply, the terms that you multiply is positive or negative. But today in this example here is very clear. 4 is positive. So we know if I multiply 4, what will happen to the direction of the sign, whether it will change direction or not. So multiply positive, it won't change the direction of the sign. So I have minus 1 minus 3x less than negative 8. Rearrange, I have negative 3x less than negative 9. And then this simple linear inequalities, I can solve and get answer x greater than 3. So what happened here is that I divide both sides with negative 3. So the inequality sign need to change direction. Watch out. And if you don't understand why it need to change directions, so just think in the way like this. Let's say I have 0 and also I have, let's say, 6. If both of this number here I divide with negative 3, what happened is that I divide with negative 3, what happened is that 0 is still 0. 6 will become negative 2. And if you compare 0 and 6, you find out that 6 is larger. If you compare 0 and minus 2, you see 0 is larger. And after the divisions, you can see the inequality sign is changes. So this is what actually happened in the idea. Go on. On the other side, okay, this side here, how to solve? Maybe if you mix a lot of students have confusion. So by right, this part here, the solution is very simple. It's just use your basic knowledge on algebra. This is just simple mathematical calculation. The things that I want to know is that if let's say I have a positive number divided by a positive number, so the result is positive or negative. This type of situation I want to check. So what I mean by that, so let's us consider this inequality. I break into 3 parts. I highlight in blue, red, and also yellow. So if I summarize this situation here, I notice that the part in yellow and the part in blue, they give me very certain about something, which is the part in yellow is always negative because negative 4 is negative. Greater than 0 is positive. So when the time I have negative divided by something, the x plus 1, we don't know is plus or minus. It can be plus or can be minus. So I put question mark. So when negative divided by something, it will give me the result of positive. So just use your common sense. This part here that I put question marks, this part here that I put question mark, it should be positive or negative so that this division will provide us a result of positive. So I believe at this moment you're clear enough. It's supposed to have the denominator is negative, which is means that the x plus 1 is less than 0. Because I want this term here turned out to be negative. The denominator here must be negative. If negative, that means it's less than 0. So x plus 1 must be less than 0. Just a simple inequality to solve. There go the answer. So my solution here is nothing to do with number line, nothing to do with table of sign, just by simple mathematical logic to get the result. And now I have solution 1, solution 2. So what we have now again, I have this solution 1, I have this solution 2. Let us try to draw a number line to put in the figures 3 and also minus 1 inside. So minus 1, 3. Draw greater than 3 and also draw less than minus 1 inside. So no matter you want to put which one on top, which one below, doesn't matter. So let's say I have it as the case of greater than 3. Not shaded because no equal sign. Less than minus 1. Again, not shaded because not equal. And watch out, the level of your drawing. One is up, one is down. And then now we want the case of union. So whichever regions on this diagram here is covered by the arrow, that will be our answer. The better diagram will be the one that I show here. So the answer will refer to the region that I have shaded. So therefore, your answer, it will be negative infinity to negative 1, open bracket, union, 3 to infinity. However, watch out for these questions here. The question asked for solution set. So by right, you should have set notation. So interval notation is not correct. To write set notation, I will have the way to write is curly bracket, variable defined here, the unknown defined here is x, then colon, the first interval, x is less than minus 1, second interval, x is greater than 3. In between these two intervals here, please don't put comma, don't put union, we put the word or. And therefore, this is the answer that we shall have. The proper way to writing is should be using the word or only, not comma, not union. Follow. Question number 3 regards on chapter 5, functions and graph. And let's see what we have in these questions here. If you realize that these questions is a bit different from what you see usually, because the whole question here, you don't see how the function is being defined, but you were being asked a lot of questions. So start from these questions here, you were told that this is a graph. Below, you're given a graph formed by, I think it's a grammar mistake here, formed by two straight lines as illustrated below. So we have two straight lines, the one that I highlighted in blue and the one that I highlighted in yellow, two straight lines here. And of course, with the labeling, as you see the point and also the intersections. A, show that the graph represent a function. Show that represent a function. So these questions here actually trying to tell you that somehow the final answer is a function. This graph is a function, but why, how, you need to show it. You show it by proving. You need to prove it. Then part B, consider the graph above represent the function of fx. So now the graph have a name, which is fx, which is also the function name fx. They ask us to do the following. State the domain and range. State the domain and range of the function of fx. Show that it is not one-to-one. State the largest possible function domain for the fx to be one-to-one. So original in part 2 is not one-to-one. Now in part 3, how can we make it one-to-one? And what is the largest possible domain so that it's one-to-one? This is what is being asked. And how we're going to solve for the following questions. Let's see. First, if you are given a graph that you want to show that this is a function, what you need to do is that you need to perform the vertical line test where you have a line which is parallel to the y-axis. In here, you may use your ruler parallel to the y-axis, and then you try to slide this line here along the graph and try to see where can we have the place that cut the graph at more than one point. If there is a place that can cut the graph at more than one point, therefore, it is not a function. If all the way you slide along is always intersect the graph at one point, then of course this is a function. Okay. In order that you have a clearer visions, the graph I mentioned is this part here I highlighted in green. My red vertical line should be always cut the part that highlighted in green at only one point. So this is the case of to show that this is a function, and how we get our answer is that, so maybe we just copy bound the diagrams for better illustrations, and then draw at any of the positions for a vertical line that cut the graph at one point, show the intersections on the cutting on the graph, so that we see that we want to emphasize the intersect is on the graph here. So our conclusion will be, by vertical line test, the graph given represent a function. So this is our conclusion. And if let's say the question want to have reasoning, the reasoning. So the reasoning is actually the observations that we perform along this test here, where the observation is that we know that all vertical line draw through the domain, cut the graph at only one point. What it mean by this statement here is actually means that, as we see just now, if I try to draw any vertical line along the domain, which is if I slide anywhere along the graph, you find out that it's always cut at one point. Of course, you may argue with me, hey, how about this circle here? Does it happen to cut at one point? Um, the answer is no, it doesn't cut any point, and it doesn't matter because there's no graph at all in this position here. This position here is not included in the domain. Okay. Of course, you can make the sentence even simpler. We can say that, let's say that we can say in the way that, if let's say the question want to have explanations, maybe we draw a vertical line. Then let's say we give a name of this vertical line here. So let's say I just simply tell that this is line L. We say that the vertical line L cuts the graph. So which graph? The graph of function f. In this, the name of the graph is function f at only one point. And then we go for this one for conclusions. And take notes, it's the vertical line, not vertical line test. The whole process is vertical line test. But the tool that we use in explanation is vertical line. So there goes the answer. And part B. If you want to consider the graph above represent a function with the name of fx, or the graph is the name of f, state the domain and range for the function of fx. So first of all, what is domain? Domain, if in terms of graph, you want to see, if you extend the graph, how far it can go to the left and how far it can go to the right. And in between here, do they have any undefined value? So I find out that by the time I extend the graph, this part here I can extend. If I extend it, you find out that it can extend infinitely. And in the view of moving horizontal, you can see that it can extend infinitely to the left. So it will go all the way infinitely to negative infinity. And then the other side here, you find out that there's a circle here, a dense circle here. So this dense circle tells us that the graph will not extend any further at this point here. So it will somehow stop at this point here. So that means from the diagram you can see the graph can travel as far as to the right until x equals to 3 only. And then in between these two end here, do I have any undefined value of x? I find out yes, there's a hole here. So I need to exclude the x value for this hole here. And as a result, my interval will be, or the domain I will have will be negative infinity until negative 2, union from negative 2 until 3. Include 3 close bracket is because you see there's a dense circle. So there goes your answer. State, that means that we can just direct right answer without any calculation. Then range, we want to see this graph here, how high and how low the graph can go by the time we try to extend. As you can see just now, there's only one part we can extend, and it extends infinitely, going up and going to the left. So in this case here, it can go up all the way to positive infinity. And how low it can go, you find out that the lowest point along this graph here, it will be at this hole here. And at this hole here, the y value is 3. For range, we refer to y value, but your range will never ever reach 3 as there's a hole there, but it can be very close to 3. So therefore, the range in this case here will be from 3 to infinity, but not include 3. It can go as low as this level here, but not reach exactly on 3, and can go as high as infinity. There goes the answer. Just observe from the graph. Next, B2. Show that function fx is not one-to-one function. To show one-to-one function, we have two techniques. One is by algebraic, one is by graphical. In this question, obviously, we are going to use graphical as we have graph there. And additionally, we don't know what is a function at all. We cannot use algebraic. So what do we do when the time we want to consider using graphical method to get that answer is that we're going to do horizontal line tests. And what the horizontal line test is that similar like just now we do vertical line test, we consider the graph as the part that I highlighted in blue. We try to have a horizontal line. You can make use of your ruler, position it parallel to the x-axis, and then we try to slide along the graph, and try to see is there any positions that I can have this line here intersect or cut the graph at more than one point. So I find out that it's possible that I can have the line cut the graph at more than one point. So therefore, if there's any of the position happens to be cut the graph at more than one point, so we know that this is not a one-to-one function. And how should we write our conclusions? And how should I write the solution is that maybe copy back the diagrams. And then in our diagram, let us put a horizontal line at the positions that you can see clearly. It intersects the graph at 2 points, or not to say specifically 2 points, I should say more than 1 point. If you can find 3 point, 4 point, also never mind. But as long as any position cut more than 1 point, if there is any position cut more than 1 point, then we write out our conclusion. Our conclusion is that by horizontal line test, fx is not a one-to-one functions. And if they want to have further reasoning, then you can mention in the way that there is a horizontal line, cut the graph at more than 1 point. And of course, you want to be more specific, and we should be more specific. You can give the name of this line here, let's say L. So the horizontal line L cut the graph at more than 1 point. Okay. In here, I just use a simple way to name the graph lah, that I just call it as L. So that we don't get confused with this line L with the line L on top for the vertical line test. If you're afraid you'll get confused, then maybe what L1 or L2 lah, or maybe you can write in general. For example, a vertical line is x equals to a constant k, x equals to constant k for vertical line. For horizontal line, it can be written as y equals to a constant k, for example, like that. Okay. Then lastly, we want to consider how can I make this graph here to be one-to-one, and what is the largest possible domain for it to become one-to-one. So if you find out, if you want to have it one-to-one, then when the time you draw a horizontal line, it won't cut the graph at more than one point. And if you realize the largest possible portions that I can happens to have is that the possible result that I can have, so that I have one-to-one, is that either this part here that I highlighted in yellow, and also this part here I highlighted in blue. These are the two possible largest part that we have for one-to-one. But among the blue and also the yellow, which one is happen to have a larger domain? This is something I need to consider. So the domain is referred to the interval of x value. I find out that for the case of yellow, it's actually between -2 and 3. Whereas for the case in blue, although you see the line here is short, but actually is start from -2 all the way to -infinity. And obviously, if you're able to reach infinity, this region here is much larger than the other one. The size here is much larger than the other one. Although you see in diagram here is short. So therefore, what is the largest possible domain I can have is that from -infinity until -2. And since -2 is undefined, so my answer is -infinity until -2 only. Again, the answer is just by observations. Okay. You can further verify lah. Is it true? If you refer to this one in blue here, I will have the case of one-to-one functions. So maybe if I just have the part in blue, then you're trying to do the horizontal line test again. Let me drag this horizontal line here down, and we try to slide along. It is always cut at one point. It is always cut at one point as I slide. So it's a one-to-one case. Okay. Therefore, this is the answer that we have. Question 4. Still on chapter 5. Mark is given 14 in this paper here. And we have a few parts there to solve, A, B, C, D. And let's see what happened in this question here. You're given a log function, and you were told that it's an onto function. Onto is an important concept that you need to take note, but most of the time you see in the question never mentions. And what is the idea of onto is that, again, if you refer to a arrow diagram, onto function is that, let's say in here I have domain and I have codomain. In the case of onto function is that all the item inside the codomain must be fully matched. Must be fully matched. All these items here must be fully matched from the domain. And in other words, for the case of onto function, the codomain is same as the range. And in here, usually in our calculation, why we ignore this writing is because we just assume all our functions here in our most of our calculation, the function is onto function. But in this question here is specific mention. Okay. Then they have a requirement. Without finding the inverse, you cannot find inverse at all. We would like to solve the following parts without finding the inverse. So never ever spend your time to find inverse, and then we try to get all this here thing here done. First, show that the inverse exists. So is it possible that there's a way that we can, without finding the inverse, and you can tell that the inverse exists? And then find the value of k for this equation here with the condition you don't know what is the inverse. And see, you don't even know what is the function of the inverse, yet you want to find the domain and range. And lastly, sketch the function f that we know and also the inverse that we don't know on the same diagram. Is it possible? And for information, all this is possible to be done. And how are we going to do so? Let's see. A. Show that f inverse exists. So for information, for f inverse to exist, it must be happen to fulfill two conditions, where it must have condition 1 and also condition 2. Both of them must be fulfilled for it to be exist. So what is the condition? Is that condition number 1? The function f is a onto function. And this is the part that usually we neglect because there's no calculations that being done all the way when the time do proving here. But now in this question, you don't have to do any proving because it's already known as is stated in the question there. So this one confirm yes. Then we only focus on the second condition. Does it fulfill? Which is I want to have f is one-to-one functions. So in other words, this one already confirmed. If you're able to prove that this is one-to-one, therefore we say f inverse exists. And for sure, the question say, for sure in this case here, the f inverse exists because usually show that question. For sure lah, this is true. The f inverse exists is true. And now we want to show how is it true. So in here, what we're going to do is that I'm going to get this answer here done by using algebraic methods only. Why not graphical? Although the question doesn't have specific requirement, is because if possible, we try to avoid using graphical method as the graph only exists on part D. So we try to avoid do something beforehand of what is required later. So that's why I want to use algebraic methods here to get the proving done. So therefore, in here, I would like to prove one-to-one. And how to prove one-to-one by algebraic method is that first we make assumption. If let's say we find out that I have x1 and also x2, both of them give me the same y value, which is fx1 equals to fx2. Then at the end of the finding, do I have both of them actually the same result? I put question mark is that, do they happen to be the same result? Yes or no, we're not sure, but we need to figure out. So therefore, we start our calculation with make assumption let fx1 equals to fx2, where of course your x1, x2 must be within the domain. If not inside the domain, then this calculation is nonsense. But most of the time, you see this part here, the condition is not written in your solution because we assume lah, we know that it should be within the domain. Go on. Substitute x1 and x2 accordingly into the function. This is what we have the following. Then reach up here to the next step. What you happen to see is that we have the bracket term x1 minus 1 equals to x2 minus 2. And in here, please don't consider as the case as compare both sides. I don't want to consider the way of compare both sides because in this calculation here, if you ever have the idea of comparing both sides, then it will easily lead you to misunderstanding where although the question is not one-to-one, because you keep on thinking of doing comparing both sides, then you find out that it's always one-to-one in the calculation. Even those quadratic that you confirm is not one-to-one, but you have the mindset of compare both sides, then it's easily make mistake there. So then if I don't consider compare both sides, how should I consider, how come both of them is the same is that, let's say if both of this value is the same, I put both of this value to become the power of a base number 3. So what will happen for the result after I put both of this number in the base number 3 here? I find out that yet they will still have the same value. They still equal to each other because the base the same, the power have the same value. And this item here, by using the properties of log and also the indices, we find out that if let's say I have log to the base A, inside the log also I have an index term to base A. Then whatever happened in the power, sorry, not this one. Let's say I have a number, index term, indices term that base A, power of a log coincidentally also base A, then whatever inside the log here, that will be the result of my answer. And of course, with the condition, in front of the log, I shall not have any negative sign or number. If there is, bring up to become the power. So this is why I can have the answer now. In front of log, no number, no negative sign. So I just take the bracket terms as a result. But this step here is not mentioned. If you want to add on this step here, you're welcome to, but it's all right that like what I show here. Just that make sure you don't have the mindset of comparable side. Let's simplify, we find out x1 equals to x2. So if x1 equals to x2, you find out that's the result, only one result. Therefore, we can say that f inverse exists for the final conclusion. And by right, you shall not from here come to conclusion direct to say f inverse exists, because this proving is actually proving for one-to-one. This is a proving for one-to-one. And how come it will lead to inverse axis is because already know is a onto. After you're able to prove one-to-one as well, so I know inverse axis. And to have more explanation, more reasoning, why is one-to-one, we mentioned the sentence here. When the time you have fx1 equals to fx2, it implies to have the result x1 equals to x2. Of course, x1, x2 is in the domain. So it is a one-to-one functions. So this is the full solution that we have. This is the extra reasoning. This is the extra reasoning to explain why it's one-to-one. Okay, then next, B. Without finding f inverse, how can I get the k value in this case here? So let's see, how can we get this answer here done? So guys and girls, the answer here is being done in the way of, let's say I try to do some drawing. Okay, let's say originally from here is 0. It undergo a function's inverse. It will give me the result of k. If the object is 0, undergo function inverse, I get the image of k. Then I find out that from this diagram here, what if I have the reversing process? This reversing process is referred to the inverse of inverse, which is actually equals to f. So in other words, from this arrow directions here is actually meant for f inverse for object 0 equals to k. Then for the one in green, object now is the k, undergo the functions of f, so fk will equals to 0. And now as you can see, I can make use of this fk equals to 0 to help me to solve the questions. So therefore, I will have f inverse 0 equals to k, and this is also equivalent to fk equals to 0. Now what you need to do is that substitute k into the function of fx. From here to the next slide, apply the idea of, let's say from log equation, how you change it to index equation is that the hashtag maintain. The base of the log become the base of the indices and become the power. So therefore in here I have k minus 1 equals to 3 power of 0. And therefore 3 power of 0 is actually equals to 1. So I have k equals to 2. This is how I get my answer here for the value of k. Then go on, C. Still, without finding the inverse, how can I get the domain and range for f inverse? I don't even know how it looks like. How I know the domain and range? Of course, some of you maybe you say that you can play cheat, you calculate the inverse of somewhere else, then state the answer. But in here, that is not the purpose we want to have this question here. The purpose to have this question here is to test your knowledge, your understanding that if you want to get the domain for inverse, you can always get it equal to the range of f. And what is the range of f? Is referred to the range. What is the function value that possible happens for this function here? And you find out the range for this function here, the function value here will be infinity to infinity. So therefore, the domain of f inverse will be infinity to infinity. And of course, the better way of writing the answer is this one that I have in green here lah. So that it is not that we simply state the answer. We have the reasoning here, the support here. Of course, you direct state tak salah juga lah, but it's good to have this one that I highlighted in yellow for explanation how you get the answer. Similarly, for the range of f inverse, if it equals to the case of the domain of f. So what is the domain of f here is that, let's just try to see what are the x value that will make this function to be valid, to be defined. So the x is located in here in the function. And to make this function to be valid, the content inside the log here, x minus 1 must be greater than 0, which is x must be greater than 1. So by right, I have 1 to infinity as the answer. So this is how we get the answer here done, without even know what is the f inverse until now. Then lastly, we want to sketch both of them on the same diagram. So how can I get the answer is that first, we consider drawing the graph of the function that we know. This is a log functions. So for log function, please be careful. I'm not sure what type of technique you're using. If you're using dice methods, then you please be careful. Check first the base number here. Do I have the base number here greater than 1 or not? It's important to take notes. I must have the base number here greater than 1. If not greater than 1, change the base to make it greater than 1. Okay. So how to change the base to become greater than 1? For example, if let's say I have log to the base 1 over 3, x, don't care lah, whatever inside lah. How I make it change to base greater than 1 is that if you have 1 over 3, 1 over 3 is smaller than 1, right? 1 over 3 is smaller than 1. So what you do is that take this one, invert the numerator and denominator, so it becomes 3 over 1, which is 3. Obviously, this is greater than 1. So you know that you want to change base to base 3. So you change base to base 3. And then the result will be minus log to the base 3 hashtag. Then only you go on further to consider graph sketching. Okay. So that's the reason why I want to do the change base, because so that you don't remember the wrong shape of the sketching. So now what I have until now is that, go on. The function is already identified. So we want to refer the shape of the graph. So the basic shape of the graph, I want you to always remember for log with the condition the base is greater than 1 is this one. Where this is occur when the time I have positive coefficient for x, positive coefficient for log. Of course, once again, the base here must be greater than 1. And now, as you can see in these questions here, the x here, I have positive coefficient of x. The log here also positive coefficient for log. So this is the shape that I want. Next, identify the asymptote, the dotted line here, the asymptote. So this asymptote here will be, I'm taking x minus 1 equal to 0. So x equals to 1. And now, reach up to this point here, we do a rough sketch in the diagram and try to see, is it necessary to find out any x and y intercept from the diagram based on the rough sketch? So I find out that, let's say, if this is the Cartesian plane, here is x equals to 1. The rough sketch, I have graph like this. I should have a y x intercept. So try to calculate the x intercept by having the log equations here equal to 0. Solve using calculator. And I suppose you find out the answer equals to 2 lah. And therefore, you can sketch the graph out now. There goes the answer for the function of f. Okay. Okay. And by the way, actually, before you start to sketch this function of f here, I want you to always remember, since you're drawing f and f inverse on the same diagram, you must make sure when time you draw the Cartesian plane, the x and also the y and also x, both of them using the same scale. That means skala dia, kalau 1 cm untuk 1 unit, 2 cm 1 unit. And in this diagram here, you need to have the reference line y equals to x, where this is the axis of symmetry, the guideline to help us to sketch the inverse. By right, your graph later will be reflect along this line here. And how we're going to sketch for the inverse is that, let's see, you find out that whatever you have in the function of f, it will also have it in the function of inverse, but it will change from x to y. For example, in this function f here, I have asymptote at x equals to 1, right? So your inverse, I will have asymptote at y equals to 1. If let's say I have the graph of f intersect at x-axis at 2, so your inverse will intersect at y-axis at 2. Then now the next thing what I want you to do is that try to sketch a graph which is symmetry to this function f here along y equals to x, which is means that you can try to tune your paper, or in your screen now you're trying to tune this in the way that have this y equals to x here turn out to appear vertical to you, and then you try to sketch this graph symmetrically along. If let's say here is the function f, try to sketch another graph which is symmetrical to it along the dotted line. So therefore, this is the graph that I have for the inverse. And make sure you label as well the f and f inverse. Don't let us guess which one is f, which one is inverse. Okay, go on. So next, we go on for the next questions. Question number 5, dealing with chapter 8 as well on limits and continuity. And now let's see what you have in the questions. You're given the function fx defined as a piecewise function in follow with 3 functions, 3 different interval. K and P are positive constant. So where we have K and P, so K, a lot of K along, and then P here. Then next, note that F is continuous from the left at x equals to K. So usually you see continuous at K, but what is continuous from the left? So continuous from the left is trying to say that, let's see, if let's say without the word from the left, continuous at x equals to K, that means limit x approach to K fx equals to fk. This is continuous at x equals to K. But what if now I have the statement from the left? That means now it's not approach to K, but approach to K minus. So this is what it means by the statement here. And then from there, we want to find out for the following. So first, we want to show K equals to 1. And then further, given one extra condition, if the limits of x approach to 1 exist, find the value of P and hence state the inverse value. And for information, if you don't know how to show part A here, K equals to 1, you can still proceed to solve P, where you just apply the result, all the K here, you replace with 1, and then further calculate. And C, I must make use of result in part A and part B to determine whether is it continuous at x equals to 1 or not. There is a missing x equals to 1. So anyway, to solve C, I must have the result for A and B first. Let us go for A and B first. Start with A. How can I solve for the value to show that K equals to 1? So far, the only information I have is the function and also this limit from the left. So as I mentioned just now, limit from the left is actually referred to limit x approach to k minus fx. Sorry, continuous from the left is actually limit x approach to k minus fx equals to fk. So this is what it means by from the left, k minus. Then I reach up to here, k minus fx, which are the one that using, which are the function we are using for k minus. So what is k minus? K minus is actually slightly less than k, which is referred to the case of less than k. So this is the function we want. So we substitute the functions. And then what is fk? Fk, a specific, exact value of k for the function will be 2. So we substitute accordingly. This is the result that we have. Then from there, we try to solve what is the value of k. You find out that direct substitution into the function here, you have 0 over 0. So we need to find out the factor create 0 and cancel it. And the strategy to solve this question here is that we multiply the conjugates top and bottom for square root of x minus k. So the conjugate is square root of x plus k. And the way we're writing the multiplication in this way here is because actually the calculation of this multiplication is that we are multiplying 1. This one is actually multiplying 1. So that's why out of suddenly why we can multiply something inside, because we are multiplying 1, where before and after the value should be maintained, but in here, 1 in this form here will change the function in some other form where will help us to solve the questions easily. Equal to 2. On the right, simplify our functions. We only expand the conjugate pair, the rest maintain in factorized form. So as a result, this is what we have. Now you should be able to see that the common terms that creating 0, we can cancel top and bottom. And the function now will turn out to become square root of x plus square root of k equals to 2. And now we should be able to do direct substitutions of k inside to get the following answer. Square root of k plus square root of k, we got 2 square root of k, which I have square root of k equals to 1, k equals to 1 shown. And once you get the k value here, now we can plug into all the info here with k here with 1. So therefore, now the functions will turn out in this form here. And the info inverse will turn out be like this. Go on. Go on. We proceed with our calculation with this info here after we get the k value for the next part, part B. You will show that note that the limit x approach to 1 exists, find the value of k, and then find these limits. Just now we just know limit exists, but what is the exact value? Don't know. So finally, we need to find out after that, after we get the p value. So how we shall get our answer here? With the info here, limit exists, find the p value. So we find out that if the limit x approach to 1 exists, that means limit from the left, 1 minus, will be the same as the limit from the right of the function, which means that I should begin the calculation with this one. Limit from the left and right is equal to each other. So it doesn't matter lah. You start from 1 minus equals to 1 plus or 1 plus equals to 1 minus. Both of them is all right. So in here, 1 plus, I find out that x approach to 1 plus is using the third function. 1 minus, sorry, this is 1 plus, 1 minus using the first function. Okay. So for 1 plus, this is the result that we have. For 1 minus, guys and girls, please, in my calculation here, if you realize, I will just have the answer here equals to f1. I doesn't do the calculation of limit x approach to 1 minus x minus 1 over square root of x minus 1 and then go for answer. But I instead do the substitution like this. What happening? So please don't forget, just now this sentence here, the information tell us that limit x approach to 1 minus fx is actually just equals to f1 because continuous from the left. That's why I can just substitute become f1. That is the reason how the calculation done in this way here. And what is f1? We can get easily from the function value 2. Whereas this limit here, we can do direct substitutions. Square both sides, we got p equals to 3. So this is how we get the answer for p. So in this part here, you need to know how to work smart to get the answer fast enough. And I don't simply just do substitutions because information tells us to do so. Then now find out what is the value for limit x approach to 1 fx. So limit x approach to 1 fx, what you need to do is that, guys and girls, again, work smart. To get the answer, what you find out is that if limit x approach to 1 exists, means that limit x approach to 1 minus equals to limit x approach to 1 plus and equal to some real number. And let's say the real number here, I has it as k. And you find out that the limit x approach to 1 is also equals to k. So in other words, approach to 1 is equal to the left and right hand side limits. And from here, I can know the left hand side limit easily equals to f1, which is 2 as just now we find out. So now in my calculations, I will have limit x approach to 1 equals to limit x approach to 1 minus the left hand side limit. And this limit here, once again, I notice that equals to f1 and f1 equals to 2. That's it, the answer. Just a short and simple calculation. Go on. Part C. Based on the result from A and B, state whether is continuous. The function f, is it continuous at x equals to 1 or not? Is it continuous at x equal to 1 or not? How we determine the answer is, let's see, what is the result we find out in part A is that we find out that in here, k is equals to 1. We find out k is equals to 1. And if k equals to 1, what happened is that this is the result that we have in the function. If we find out that f1 equals to 2, so from here, we see that f is defined. f1 is defined. So condition number 1 fulfilled for the continuity. Then part B, according to the questions, they say if this limit exists, so it exists. So automatically fulfill question condition number 2. And what is the limits here is that it is equals to 2. Or in other words, we find out that the limit x approach to fx equals to 2, where it also implies that the limit exists. So now, using these two info that we have, what you do is that we try to compare the function value f1 and also the limit value, are they equal to each other? And then we come to conclusion, is it continuous? So the reason is that we say that the limit and also f1 is equal to each other and equal with the value of 2. So f is continuous at, I think there's a missing term here, continuous at x equals to 1. Therefore, this is our answer. This is the reason. Below is the conclusion. So again, check in the screen here now. The x equals to 1 is missing. It just show equals to 1. Should be x equals to 1. Then we go on further for the next questions. Questions number 6. The second last questions here. So the second last questions, let's see how we have the solution here. So this answer here is not being hidden. So we just go through the solutions on how to solve for these questions here now. Okay, let's see in the question A here. This is regard on chapter differentiation. 60 marks is given for this question. We have part A and part B. A and B are two independent questions. Dia tak kacau sesama lain. So in part A here, evolve of the case of implicit functions. Not really implicit function. Sorry, this is not implicit function. This function here can be actually rewrite it as y equals to something function of x. But of course, we don't do something like this, as the rearrangement will make things looks complicated. So in here, although this is not an implicit function, but we're going to perform implicit differentiation, as and the time you differentiate this part here, it will go through implicit differentiation. And then along the differentiation, we try to able to prove this equation out. And from this equation, you can see that we have only first derivative. That means from the original equations, we go to differentiate for one time and then try to get this equation. B, you're given a function in this form here, and they say by using logarithmic differentiation, show that the result of the differentiation is this following. So the instruction seems to be simple, but how is the procedure should be done? Let us have a look. Question A. Along in the proving here, you find out in the questions. Originally in the questions, you find out that it consists of y term, it consists of c. But after you do differentiation and get the final answer, you're supposed to find out that the y and c is disappear. And how does that possible to happen? Let us have a quick look on our calculations here. So let's see. If I happen to break the functions, the original function into three parts. The first part highlighted in blue. The second part highlighted in yellow. The third part highlighted in pink. We're going to differentiate each of these part here with respect to x. We're going to differentiate that with respect to x. And let's see what is the result I will have here. If I differentiate them with respect to x, each one of them. So I find out that for the part in blue, it will need to go through product rules to get the result as follow, where we have u, v. So this will be the answer that we have is check back. I think there is a miscalculation here. I suppose here I have a multiply of 2. Maybe it's a typing error. Should be 2x squared. So I should have the case of u, v prime, v, u prime. Then for the part in yellow, when the time I differentiate, I got minus 4cx. For the part highlighted in pink, when the time I differentiate, I got 4. So reach up to this moment here, what you happen to see is that yet you still see that you still have the c inside the equation, not same like the one proving, but the differentiation process is already done. But no worry, let us slowly get the question here done. So reach up to here, the next thing what you happen to see is that let's just try to compare the differentiation result that we have with the final answer that we want to achieve. So we see the first derivative, the derivative part. We find out that as opposed to have it come with power of 3, but my result just come with power of 2, and further I have a 2 there. So I need to find somewhere to get rid of this constant 2, and I find out that I have common factor for each one of them. So I divide them with 2. So therefore I have the following result. Then next, as you can see, after getting rid of 2, I have x squared multiplied with dy dx. But the question have x power 3. So I want to have the x power 3. The whole equation I multiply with x. So power of 3, x squared, 2cx squared, 2x. Then reach up to here. What you happen to find out is that I already achieved this form here. We are almost there to get this answer. However, if according to the question, I'm not supposed to have any x or y term or c term. So how can I get rid of these two terms here is that if you realize in your equations there, the part that I highlighted in purple is the same, where it can actually substitute become 4x plus 3. So now, at this point here, you substitute the part in purple accordingly. You see the y term and c term is gone. And then in order to achieve the final answer, what you need to have is that you need to have the right hand side become 0, and you need to have the terms turn out to become 2x plus 3 come along with the x power 3 dy dx. So therefore, you find out that if I have this term here rearranged to the other side, or in other words, I minus 2x on both sides of this equation, therefore I have achieved the equation that I want to prove. I have shown. There goes the answer. Next, part D. Given the functions x over e power of 2x square root of x squared plus 1, the question said by using logarithmic differentiation, show this equation. So logarithmic differentiations, that means I want to differentiate log to solve these questions. And originally in the function, there is no log there. So how we use logarithmic differentiation to solve the question is that let us, from this function here, we try to do something before we do differentiation. And the something we want to do is that we have it come with log. And therefore, in our calculation here is that we're going to insert log on both sides of the term. And as a result, this is the one we have. This is the one that we have. We have log them both sides. So we have log them both sides. And after you insert log, you don't directly do differentiation, because in logarithmic differentiation, before you differentiate, you need to apply the law of log first. And what are the law of log that we're going to apply here is that first, if let's say I have the case like this, A over B multiply C, so the result will be ln A minus ln B minus ln C. So therefore, we split that out accordingly. Next, what we're going to do now is that we don't differentiate yet, but yet we try to simplify these two terms here. I highlighted in yellow and highlighted in blue. Where what we find out is that for the one highlighted in yellow, I can simplify it become 2x based on the property log to the base a to the power of hashtag. The answer is hashtag. In this case here, ln is actually log to the base e. So therefore, I get 2x. On the other hand, for the one in blue here, how come it can reach to this form here of the result is because I apply two things here. Maybe I want to write one extra step for the changes for these two is that square root become power of 1 over 2, and then the power we can bring to the front. And now at this moment here, suppose there is no rules of log that I can apply anymore. Then I start my business on differentiations. So how we do differentiations of log for this part here, recall. If you differentiate, let's say log to the hashtag, so the result will be, take the hashtag become 1 over, then we multiply with the differentiations of the hashtag. In this case, if the hashtag is happen to be fx, so it will turn out to become 1 over fx multiply f prime. Where this one we can simplify, just write it as f prime over fx. Then the rest differentiate 1 over x, differentiate 2, differentiate this one here. How can I get this result? Let me write one extra step, 1 over 2. So make x squared plus 1 become denominator, 1 over x squared plus 1, multiply with differentiation of the content here, which is 2x, simplify it. So this is how I get the answer, x over x squared plus 1. And then reach up to here, what I need to do is that there is a specified form that I want to achieve, where the specified form is that I want to have it in a single fraction. So what I need to do now is that let me group all these terms into one single fraction, and it will come with a common denominator of x squared plus 1. In order for you to have a clearer vision how I get the following result here, so let me highlight the terms, the partial fraction I have here in red, in yellow, in blue. If I want to make them with a common denominator, what will happen is that the one in red, it will turn to become x squared plus 1 on top. And if you try to check the one in red now and the denominator, if I do cancellation, it's supposed to have the answer 1 over x as the previous line. For the one in yellow, if I do cancellation with the one in green, I will get back 2. Then lastly, same for the one in blue. Same for the one in blue. If I do cancellation with the denominator in green. So now I can simplify further my answer as the following step, where I expand the part in yellow, simplify all the single terms here. I got this result, 1 minus 2x power 3 over x squared plus 1. And you find out that the numerators, it looks alike that the proving that we want to achieve. Now, how the exponent and the square root come in. So if you realize, all the while, the one on the left-hand side is f prime over fx. We just want the answer f prime equal to something. We don't want the fx divided with it. So the next line, I multiply the fx to the right-hand side. Now this is what we have. And substitute the fx accordingly. Then we try to do simplification. I find out that the x and x can be cancelled off. And then x squared plus 1, square of x squared plus 1. I can simplify it, become this term here. Then the rest just copy back accordingly. Therefore, once again, we have done the proving shown. Then finally, we come to the last questions. Regards on chapter 10. Applications of differentiations. And let's see how we solve for these questions here, guys and girls. So, you were told that an inverted cone with the height of 12 centimeters and a diameter of 8 centimeter was initially fully filled with water, and if water is drained from the cone at a steady rate of 2 pi centimeter cube per second, find the following. So from the starting of the sentence, you were told that there is an inverted cone. That means the cone in these positions here. Initially, it's full of water, but as times go on, there's leaking happening. The water is being leaking out from the cone, and you were told that it is drained out in this rate here. So if let's say I consider the V is actually the volume of water in the cone. So the rate of change of the volume of the water in the cone will happen to be 2 pi centimeter cube per second, come with a negative sign because the volume is keep on decreasing. So although the question never have negative sign, but based on our understanding, if we discuss the V as the volume of the water inside the cone, by right it should have the rate of negative because the volume is decreased from time to time. And then with this information here, what we want to find is that we find the rate of change of the height of the water when the time the height of water is 6 centimeter. So that means if I try to have a diagram being drawn, if let's say after some time the water level drop until here. So this is the water level at that particular moment, let's say H. So the rate of change of height of water, that means I want to find the rate of change of this H here. I'm looking for dH dt when the time the H is 6, according to the question. And then next, I want to know what is the time taken, how long it will take to completely drain out all the water. And now, in order to get this question, after we understand some idea here, let us see the strategy to solve. So based on the info we have, is that originally we have a cone with this dimension here as being drawn. And of course, initially it is fully filled with water. So maybe in this diagram here, I add in the drawing, I highlight in blue to show that it's initially full of water. But maybe after some times, the water is being drained out. So therefore, after some time, maybe the water level is dropped until here. And then now, in order to solve the question to find dH dt, and we have the info of dV dt, so what you find out is that according to the routine way of thinking and calculation, we will use chain rule to find dH dt by using dV dt multiplied with something. And what is the something here is that, right, by chain rule, you know that you should use dH dV. And how to get dH dV? Find a formula or equation dealing with V and also H. And what is V? The volume of the water inside the cone. H is the height of the water in the cone. So to get this equation dealing with V and H, we can consider the volume of the water in the cone by using the cone formula. As you can see, when the time the water is filled in inside the cone, it have a cone shape. To get the volume of water, you can just calculate the volume of the cone shape of the water. So therefore, the volume of the water V by formula is actually 1 over 3 pi r square h, where this is the r, this is happen to be the h. However, if you realize the derivative you want to find is this one, just with v and h, but the formula now with r. So we need to find something to replace the r, and this is what we usually do for the case of cone. We always want to find the relationship between r and h, and in order to do that, we can make use of the side view of the cone, this part of the cone, this side view of the cone, half of the cone, and I have a right angle triangle in this form here. And I find out that if at the instant that the water level is at this point here, the water itself form another triangle beside the cone shape. Both of this triangle is a similar triangle where I can find out the relationship between R and H in the way of, for example, if I have R divided by H, so the two sides of this smaller triangle divide each other should have the same value of the two sides of the larger triangle. These two sides of the larger triangle divide each other correspondingly. So therefore, R divided by H should be 4 over 12. And therefore, I find out R is actually equals to H over 3. So now, substitute the R in this formula here with H over 3. I have the volume equals to 1 over 3 pi R squared, which is H over 3, multiply H. Simplify the answer. I suppose I have the answer as pi H power 3 over 27. Where this part here, if you try to expand, is H squared over 9. So H squared multiply H power 3, 9 multiply 3, 27. Then reach up to here with V equals to pi H power 3 over 27. We find out dV dH is actually equals to pi H squared over 9. Differentiate this term here. And I purposely write in one single fraction term here so that when the time I have dH dV, where I need to overturn this one here, for the sake of finding dH dV, it will easy for me to interchange the denominator and also numerators. And now, in order to find out what is we have for dH dt, which is equals to the dV dt multiply dH dV, or you can have dH dV multiply dV dt, doesn't matter, as long as both of them is there, no matter which one comes first. So therefore, I have the following result. So check. This is actually the DHDV. The other one is the dVdt. Again, just now I say, how come that is negative? Because if V is the volume of the water in the container, from time to time, the volume is decreasing. So it's a minus sign. So therefore, I have my dHdt as the following. Negative 18 over h squared. And from here, what you can see is that the rate of change of the height is not the same all the time. At different moment, it will happen to have different rate. And as you can see for this value here, negative 18 over h squared, we can see that if I have the water level is getting lower and lower, then the rate of change of the height will be getting higher, or the decrement of the height will be getting faster. So now next, what is so important about this DHDT here written in this form is to take notes that the rate here is not a constant rate. It's not from time to time it decreases the same water level. And this is important later for the time taken for time taken calculation. So that's why I want to emphasize the form in here. And now I don't want, actually the question don't want to find out the answer for DHDT in general like this. They want to find out in a particular moment. And the particular moment here is when the height is 6 centimeter. So we substitute h inside, we have DHDT equals to 0.5 centimeter per second. And it comes with negative sign because as the water drain out, the h here is all getting smaller and smaller. It's decreasing the h value. Okay. So this is what we have for the value. Okay. So at this moment here, the statement answer to explain what is this calculated answer is not stated here, but later you refer to the answer scheme that I post in Google site. I will add back lah for the result here to interpret what is the figures you calculate out in sentence. Where the sentence I can write here is that can say something like the height of water decreases at the rate of 0.5 centimeter per second. So you see in the sentence here, I doesn't use the I doesn't have negative sign. Is because the decrease already indicate the negative sign. And what is the situation that I can have negative sign, or I should write negative sign for the 0.5 here? Is that maybe if you use the word changes maybe increase or decrease. To make it clear, the changes is decrease or increase. We put in the plus minus sign in the rate like this. So depends lah, which are the words that you want to use, then the corresponding value as shown in here. The very last questions. Now, we want to know what is the time taken for the originally fully filled cone to be completely drained out. The water completely drained out from the cone. That means the cone finally will be totally empty. From full to become empty. And how we shall get our answer here is that, so time taken, the general formula will be equals to, we take the quantity divided by the rate of change of the quantity. We take a quantity divided by its rate of change, and the rate of change here must be a constant rate. Must be a constant rate. Where from the beginning until the end of the process, the rate never change value. And in this case here, between the unknown V, H, and also R, our choice will be refer to the V, the volume, because you was told that the changes of the volume happen in steady rate, where from time to time it always decrease in the rate of 2 pi centimeter cube per second. So I would like to use this rate of change to get my answer. So originally, what I should have for my since I'm using volume, so therefore now is V over dV dt. And originally, what is the volume that I have here is that I need to calculate using the volume formula. And if the water is completely drained out, that means um, the volume of water that is completely drained out will be happens to be the full volume of the cone. So therefore, I will have the answer, the volume equals to, substitute with the height of 12 inside. So answer is 64 pi. So in this case here, this is actually the volume of water that happened to be drained out. And then to get the time taken here, if it happens to be equals to, let's say I use t equals to v over my dv dt. And in the here, you find out that the rate of change, I doesn't use negative sign. I doesn't use negative sign here because this is happen to be the rate of change of the water drained out. And in order to calculate time, I should not consider any negative sign. So both of these, I should not consider negative sign. I should exclude negative sign for calculations because time shall not have negative, because we don't back to the past. If time is negative, as if like we can back to the past in this case here. So therefore, the time taken here, if it happens to be 32 seconds, that goes the answer. So therefore, finally, lah, we have finished discuss the full paper here. Then one more discussion. The rest of the discussions that already discussed, you can see in the Google site. The one that's not, then you need to wait for the date that is given there. So thanks for joining for this meeting here. So although the view at this moment here is very low, but still feel very thankful for those of you that is here to join me. Thank you very much and goodbye.